General methods of preparation. Next one. Next topic. General methods of preparation. General methods of preparation from haloalkanes. Right. First one. The first one we have here as methyl chloride. Methyl chloride. The in the first chapter, whatever we people have prepared, we have studied preparation here, most of them. Okay. When you take a methyl chloride, methyl bromide, or ethyl chloride, any alkyl halide, you can even take a aryl halide also. Okay. Treat this with sodium hydroxide. Treat this with sodium hydroxide in presence of aqueous medium. In presence of aqueous medium, complete the equation. Complete the equation. What is it we get here as? CH3OH, methanol, CH3OH, formation of methanol, that is nothing but NaCl. General methods of preparation. Okay. Right. Next one. C2H5Br, ethyl bromide. Ethyl bromide. When you treat this with potassium hydroxide, aqueous medium, we get here as C2H5OH, eliminating KBr. Any strong base you can use here. Okay. CH3Br, on treating with silver oxide, Ag2O. The condition here is again aqueous condition. Condition is aqueous condition. Actually, what happens when you use a aqueous medium, the silver oxide, that is nothing but Ag2O, gets soluble in water. Boys, I want pin drop silence. Shh. Right? Silver oxide first gets soluble in water. It forms two molecules of AgOH. It forms two molecules of AgOH. Right? So that I'll get here as CH3, eliminating two molecules of AgBr. Eliminating two molecules of AgBr. When you use silver oxide, it gets soluble in water, forms silver hydroxide, which reacts to give AgBr. Okay. Now, the second condition is, see, supposing if I use your methyl bromide, tomorrow you people have again D and F block test. The test has been given. Those who haven't don't write. The rest who has not written will be writing the test. Okay. CH3Br, you will make this to react with Ag2O. You will make this to react with Ag2O. You will make this to react with Ag2O. But here you are just heating it in presence of dry. That is nothing but you are not going to use any aqueous medium. Okay. I repeat, concentrate towards the board. See here, the condition here is, in the previous case what we did was, we took Ag2O in the aqueous condition. Okay, when you take Ag2O in aqueous condition, we get an alcohol, whereas same Ag2O, I'm using it in dry. Okay, when you use it in dry, what exactly happens is, you will be using silver oxide in excess. You will be using silver oxide in excess. So what happens is, two molecules, what happens here is, it will react with AgBr. AgBr will be reacted here. So you will get here as dry ether, that is nothing but CH3O, CH3, with elimination of two molecules of AgBr. So which we call it as dimethyl. We call this as dimethyl ether. Dimethyl ether, that is, if you use excess of alkyl halide. If you use excess of alkyl halide, we get a dimethyl ether. So whenever you read a question, please go through the condition and then answer, especially the organic part. Okay, complete the copy down the equation, think over it. Okay, right, next one. Next one, preparation from alkene. Preparation from alkene, right? Overall in organic chemistry, we people have 6 mechanism. Out of 6 mechanism, for your example, you'll get 3 mechanism, which is very important. Okay, between in the first chapter, we people have studied SN1, SN2 mechanism. Out of these 2 mechanism, any one mechanism will be given to you. Okay, in this chapter, we people have 3 mechanism, that is nothing but conversion of an alkene to alcohol, conversion of alcohol to an alkene, and conversion of alcohol to ether. Okay, this is a part of it. Write down preparation from alkene. Under that, hydration of an alkene, hydration of an alkene, hydration of an alkene, that is CH2 double bond CH2, which we call them to be as a ethene, which we call it as ethene. Okay, you'll be treating this in presence of an acid. You can take sulfuric acid, concentrated sulfuric acid, which acts as a dehydrating agent and protonating agent. Okay, so in presence of sulfuric acid, water will ionize as H plus and OH minus. Okay, to any of this, since we have a symmetrical carbon atom, OH can be added up anywhere. That is nothing but we will get here as CH3 single bond CH2 OH, which we call them to be as a ethanol, which we call it as a ethanol. Take your time, understand and copy down. No dreaming and no admiring each other. Okay. Same thing if I take an unsymmetrical alkene, that is nothing but propene, unsymmetrical alkene, that is a propene. Do you remember in first PUC we people had studied Markovnikov's rule? Right? The negative part get bonded to the carbon atom which has a lesser number of hydrogen. So same thing, what you'll do is you'll take a water molecule in presence of sulfuric acid. We have here as H plus and OH minus ion. The negative part get bonded to the carbon atom which has a lesser number of hydrogen. That is, we get here as CH3, CH, OH and CH3. 2-propanol as a major. We get even 1-propanol, it as a minor product. Both major and minor product will be formed. Okay, done. Next one, write down the mechanism, mark it as important. It is a 3-marker question. 3-marker question. 3-marker question. Mechanism of conversion of ethene to ethanol. Mechanism of conversion of ethene to ethanol. Ethene to ethanol. Under that, step 1, electrophilic attack of hydronium ion. Electrophilic attack of hydronium ion on alkene 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 to give a carbocation an intermediate product. Why I am giving such specific electrophilic and all? No, in your competitive exam they'll ask step 1 for the conversion of an alkene to ethanol. What is it a electrophilic or a nucleophilic substitution reaction? Okay, so you people should have to know that electrophilic attack by hydronium ion on alkene gives a carbocation as an intermediate. Okay, intermediate or intermediate product. It's okay, no problem. Right, now see here, H plus ion, H plus ion, right? H plus ion is an acid. You'll make this to react with water molecule. You'll make this to react with water molecule. Lone pair will attack here and we'll have here as H3O plus, H3O plus, which is an electrophilic hydronium ion, which is a electrophilic hydronium ion. Slowly you can copy down along with me. Otherwise, you will hurry up and sit admiring each other. Please do not do that. Hydronium ion, right? You will take here as CH2, double bond CH2. You will make this hydronium ion, which is an electrophile. Hydronium ion, look over to the board. Hydronium ion, which is an electrophile. The double bond attacks the H plus ion. Oxygen will pull the electron towards itself, right? So that I'll get the product as CH3 single bond CH2 with a carbocation eliminating a molecule of water with a lone pair of electron. Since there is a formation of a carbocation, it is a carbocation. And why are you getting a carbocation? Because we have an electrophile. Okay. The first step is a electrophilic or nucleophilic, right? And it gives rises to which stable carbocation. So it gives a stable carbocation. Okay, this is step 1. Whereas in step 2, what exactly happens is the nucleophile water, since water is in excess. Okay, when you take a water is a neutral, right? Water is a neutral, it is not a positive or negative. But here what happens is when you have water molecule in excess, when you people have it in excess, what happens is water molecule acts as a nucleophile. Okay, so in step 2, what exactly happens is water molecule has a lone pair of electron. This lone pair of electron attacks the carbocation and we'll have here as CH3, CH2 and then oxygen and 2 hydrogens. Oxygen has a lone pair of electrons and a positive charge. So this we call them to be as a step 2 reaction, attacking of a nucleophile. Okay, just go through both the steps once. That is, an H plus is an acid in a molecule to give a electrophilic hydronium ion. That is a positive charge. Positive charge is called as an electrophile. Which one? H3O plus, we'll use it here. No, this is much H3O, right? Step 3 is nothing but the water molecule. The water molecule reacts with that of the protonated alcohol to give deprotonation. To give a deprotonation. O minus will react with H plus ion. The electrons will be shifted, right? It gets deprotonated. We get here as alcohol, that is CH3 to O with formation of H3O plus. With formation of H3O plus. Okay, so that you can prepare here the alcohol. They can ask you any alcohol over here, but generally for your syllabus we have ethanol to ethane. Okay, next one, next preparation, second preparation, hydroboration reaction. Next one, hydroboration reaction. Hydroboration reaction, mark it as important. Hydroboration reaction. Addition of water takes place through anti-Markovnikov's rule. Underline that, through anti-Markovnikov's, Markovnikov', anti-Markovnikov's rule. Okay, right. In anti-Markovnikov's rule, generally what happens, no? We people have this B2H6. B2H6, we call them to be as a diborane. Okay, we call B2H6 as a diborane. Actually, it decomposes to form here as BH3. It decomposes to form BH3. BH3 contains the odd number, right? BH3 really even number, odd number of electrons there. That is highly unstable. So what? So in this reaction, we are going to take only BH3, which acts as an electrophile. Okay, BH3 acts as an electrophile, so that, and in this particular reaction, no, we people can prepare only primary alcohol. We can prepare only primary alcohol, not the second. Is it clear? Right? Write on the BH3. BH3 is an electrophile. Addition takes place in the terminal carbon and generates slightly positive charge on second carbon, which is stabilized by plus I effect. Okay. Now, basically what happens is, we are going to take here as CH3, CH, double bond CH2. That is nothing but propanene or 1-propene. Okay. You will make this to react with BH3. You will make this to react with BH3. Fine. You can copy it down simultaneously. You will make it to BH3. Make it to react with BH3. The double bond attacks the BH3. The double bond attacks the BH3 because BH3 acts as a electrophile, right? So that I'll get here as CH3, CH, single bond CH2, and then a BH, single bond BH, and this carbon atom will have a positive charge. Okay. Now what exactly happens? This carbon will try to pull the hydrogen from here. It will try to pull the hydrogen from here, so that I'll get the compound as CH3, CH2, CH2, BH2, BH2. One of the hydrogen will be added to the second carbon atom, and then we get BH2. Like this, you can show 3-step reaction. One more molecule of CH3, CH, double bond CH2, so that we get here as CH3, CH2, CH2. Okay, right? So that I can substitute both the hydrogen atom, and I'll get here as 3 molecules of B. Okay, this has to be followed with hydrolysis. This has to be followed with base hydrolysis. Basic hydrolysis, acidic hydrolysis and basic hydrolysis we have. It is a basic hydrolysis, so that I'll get here as H3BO3, H3BO3, and 3 molecules of propanol. And remember, we can prepare only primary alcohol here. We can prepare only primary alcohol. Have a look of one's complete equation. Next preparation, oxy-OXY, oxymercuration. This particular preparation is important for the competitive, not for the theory. Okay, oxymercuration reduction, oxymercuration reduction. Okay, take again the propene, CH3COO minus. What is the charge on mercury? Hg, +1 or +2? +2. So what will be the formula for mercuric acetate? What will be the formula for mercuric acetate? It will be CH3COO twice Hg. Okay. So now I will subject this to mercuration. That is nothing but CH3COO twice Hg. Copy down this. CH3COO twice Hg, followed with hydrolysis, followed with hydrolysis, followed with hydrolysis. Okay, so that I'll get here as CH3, CH, here it will be OH, single bond CH, here it will be OCOHG, 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 or HgCOOCH3 also you can write. Okay, you can even write this as, you can even write this as HgCOOCH3, COOCH3, COOCH3. This has to be treated with sodium borohydride. This has to be treated with sodium borohydride. That's why we call it as oxymercuration reduction. NaBH4 is a reducing agent. NaBH4 is a reducing agent, so that we get here as a secondary alcohol, CH3, CH and CH3. People prepare here as a secondary alcohol. Every day do practice 5 to 6 equations. Okay, at least August 15th, I think you people have your unit test 1. August? Then start preparing for it. Write down. In hydration, there is a formation of carbocation, whereas in demercuration and hydroboration, there is no such formation. Okay, next one, preparation from carbonyl compounds. What are carbonyl compounds we have here as? C double bond O, we call it as a carbonyl compound. Right, give me the list of the carbonyl compounds right now. Stop writing and give me the list of the carbonyl compounds which you people have studied in first PUC. First chapter, organic chemistry, nomenclature. Right, in that we have studied all the functional groups. Right, in that we people have a carbonyl group. This is called as a carbonyl group. Okay, give me the names of the carbonyl group which you people have studied. For example, I'll start with the first one. What we people have is RC double bond OH, which we call them to be as an aldehyde, which we call it as a aldehyde. Yes, go ahead now. RC double bond, RC double bond, R. What is it called as a? It is called as a ketone. This we call it as a ketone. Right, girls, I want the names. Right, next. Alcohol, we don't have this RC double bond O. It's a third one. We have a carboxylic acid, RC double bond O, OH, which we call this to be as a carboxylic acid. Right, we have a carboxylic acid. Next, we have an ester, RC double bond O, R dash, which we call them to be as a ester. Right, and then we have here as next RC double bond O, Cl, which we call them to be as a acid chloride. This we call it as a acid chloride. Next one, this is your fifth one. Sixth one, we have the RC double bond O, NH2, which we call it as a amide. This is called as a amide. So many compounds which are with the carbonyl groups. Okay, these are all derivatives of, some of them, esters, acid chloride, amide, are all derivatives of our acid chloride. You should be familiar with all this now. Right, copied on everything. Next, what do you mean by reducing agent? What do you mean by reducing agent? You are going to remove the oxygen, add up the hydrogen. We will not talk about the electrons here. Okay, reducing agents means the agent which removes the oxygen, adds up the hydrogen, we call it as reducing agent. Especially in organic chemistry, no, they don't ask you that, okay, you people have studied first chapter, we'll ask a question on the first chapter. No, they'll mix up all the 4 chapters, and you people should be familiar with the catalysts. Okay, you should be familiar with the catalyst. If you use sodium and ethanol, what happens? Lithium aluminum hydride, what happens? You have to be familiar with. Okay, take down the list now. reducing agents, platinum, palladium and nickel, comma, sodium in presence of ethanol, lithium aluminum hydride, sodium borohydride. Okay, we'll start preparing from these compounds. Now, first, I'll take it as CH3, C double bond O, H. You can even write it as CHO. Okay, to specify, I'm writing it as C double bond OH. How many carbon atoms we have here? 2 carbon atoms. So we call them to be as a ethanol, right? Aldehyde ends with NAL. So we call it as a ethanol, or its common name is also called as acetaldehyde. You need to be familiar with both. Okay, ethanol or acetaldehyde. So in this, I don't have to remove oxygen, it is just addition of hydrogen. So what I'll do is, I'll be using as a nickel as a catalyst. I can use either nickel, platinum or palladium, any one catalyst. It provides me hydrogen molecule. Okay, it provides me hydrogen molecule. So what it will do is, I'll take it as CH3, CH2, CH, CH3, CH2 and OH. Okay, which we call it as a ethanol. So remember, whenever you use any aldehyde, when it's subjected to reduction, you'll get alcohol. Numericals will be based on aldehyde will always gives you primary alcohol. Same thing if I use a ketone, like if I use here CH3, C double bond O, CH3, which we call it as acetone. Common name is called as acetone. IUPAC name we call them to be as a 2-propanone. Okay, it's called as a 2-propanone is a IUPAC name, whereas common name is acetone. For this, I'll subject it to reduction. I'll be changing the catalyst here. I'll be using it as a platinum, so that I'll get here as secondary alcohol. I'll get here as secondary alcohol. OH will be, hydrogen will be added for both carbon as well as the hydrogen, so that I'll get here as a secondary alcohol. So in general, what do we say is, aldehyde gives a primary alcohol, whereas ketone gives a secondary alcohol. Okay, copy down. Next one, preparation from carboxylic acid and esters. Okay, carboxylic acid, for example, I'll take here as acetic acid. Carboxylic acid, I'll take here as acetic acid. Okay, acetic acid, the problem here, we get a nascent hydrogen. You can use here as lithium aluminum hydride, or you can even use here as B2H6 in presence of B2H6 in presence of ether, followed with hydrolysis. B2H6 in presence of ether, followed with hydrolysis. Okay, so that I'll get here as alcohol CH3, CH2, OH, eliminating a molecule of water. Eliminating a molecule of water. That is a primary alcohol we get. Primary alcohol. Okay. Now, how do you name an ester? For example, see here, ester, already we people have written a general formula, that is nothing but RC double bond O, O R dash. Okay. Anytime you will name first R dash and then you will name the RCOO group. For example, I'll take here as CH3, C double bond O. Oh, what is this called as? What is this called as CH3COO? Just now you people told me what is CH3COO? What is CH3COOH? What is CH3COOH? What is the name of this? Which carboxylic acid is this? Which carboxylic acid? How many carbon we have here? 2 carbons. So what is the name of this carboxylic acid? What's the name of this carboxylic acid? Okay, what is the ending name we give for carboxylic acid? Oic. So what is this called as a ethanoic acid, or it is also called as a acetic acid. CH3COOH. I've splitted this and written, that's it. CH3COOH is called as a acetic acid, or it is also called as a ethanoic acid. If I remove hydrogen, what is it? We call them to be as a acetate. It is also called as a ethanoate. CH3COO is called as a acetate, or it is also called as a ethanoate. Supposing if I fix here C2H5, what is C2H5? What is C2H5? Okay, what is C2H6? Ethane. What is C2H5? Ethyl. Now this is ethyl, this is acetate. Together we call them to be as a ethyl acetate. That is how we name an ester. Ethyl acetate. Ethyl acetate. Okay. Now this particular ethyl acetate, we are going to treat this with lithium aluminium hydride followed with hydrolysis. Lithium aluminium hydride followed with hydrolysis. Lithium aluminium hydride followed with hydrolysis. Okay, we get here two alcohols, the bond will break here. We get two alcohols, that is nothing but we get here as CH3 CH2 OH plus C2H5 OH, two molecules of ethanol. Two molecules of ethanol. Write down. For esters, the reducing agents are lithium aluminium hydride, sodium in presence of ethanol, and copper chromite. Chromite, CHROMITE, copper chromite. Ethanol, ETHANOL. Okay, right. Next paragraph, reduction of aldehyde, ketone and esters with sodium and ethanol is commonly called blank BLANC, blank reduction. Okay, next one, preparation from Grignard, GRIGNARD, a reagent. Now all of you keep your pen, concentrate here because this is a important, which is a commonly asked question. Okay, now you can take any carbonyl group. Okay, I'll tell you which carbonyl group gives you what. Now, supposing if I take a carbonyl group, for this I'll be taking Grignard reagent, that is nothing but RMgX. Okay, RMgX in presence of dry ether. In presence of dry ether. The question is, if you don't use a dry ether, we get a high carbon, right? Because for presence of water molecule, the reagent will come and attacks the carbon atom here, and oxygen will have a minus sign. Okay, concentrate here, later you can see your hand, right? See, R will come and get bonded to the carbon atom, the electron shifts will have a minus sign. The minus will react with Mg group. Okay, minus will react with Mg group, so that I'll get here as C, here it will be OMgX, here it will be R, and here will be some groups. Okay, this you have to subject it to hydrolysis. Whenever you treat it with Grignard reagent, it has to be followed with hydrolysis. So you will subject this to hydrolysis, that is nothing but water molecule in presence of an acid. Mgx will take up the OH group. Mgx will take up the OH group, so that we get here as Mgx and here it is OH. Then the carbonyl, that is nothing but oxygen, will take up the hydrogen, which we have it here, and then we get the group here. It can prepare, we prepare tertiary alcohol, right? Now, keeping this in mind, what a first copy down this equation, I'll give you the rest of it. Copy down the equation. Copy down the equation. Understand and copy down, because based on I'm going to write three equations more here. Done? Right. Now, the first example is you're going to take formaldehyde. Guys, I want everyone to answer this question, okay? Formaldehyde, which we commonly called as formaldehyde, IUPAC name is called as a methanol. Formaldehyde, you'll make it to react with methyl magnesium bromide. Tell me which alcohol you get. Complete the equation. Which alcohol you will get here? Do it. I want the name of the alcohol. And tell me which alcohol you will get. Which alcohol is it? Primary, secondary or tertiary? Complete the mechanism, you will answer the question. The previous one was a general one. So what about this? We get a primary alcohol. Just check whether you get a primary alcohol there. Right? We get here as hydrogen, carbon, oxygen is nothing but MgBr, and again here it is a hydrogen, here it is CH3 group. Subjected to hydrolysis, so that you get here as CH3, CH2, OH, eliminating Mg and then OH here and Br, which we call them to be as a primary alcohol. Other than formaldehyde, if you use any other alcohol, other than formaldehyde, if you use any other aldehyde, you get here as a secondary alcohol. Girls, listen to this properly, right? If you people use a formaldehyde and treat with any Grignard reagent, you get a primary alcohol. Other than formaldehyde, if you use any other aldehyde, you get a secondary alcohol. Example, take acetaldehyde, CH3, C double bond OH, treat this with C2H5, MgBr, complete the equation. C2H5, MgBr, complete the equation. And tell me which alcohol you get here. Same mechanism. This is a primary alcohol. The carbon to which OH group bonded, you have two hydrogens here. Right? If you have two hydrogens, it is called primary alcohol. Mention that. Dry ether, so that you get here a CH3, CO, MgBr, and then here it is hydrogen. Here you get C2H5, subjected to hydrolysis, sorry, you get a hydrocarbon. Subjected to hydrolysis, you get here a CH3, CH, here it is C2H5, OH, forming Mg, Br and OH. So other than formaldehyde, if you use any other aldehyde, you get a secondary alcohol. Other than formaldehyde, all such questions will be asked in your competitive part, the major part. Right? If you use other than formaldehyde, if you take any other aldehydes, you get a secondary alcohol. Third one, use ketone. For example, acetone, and then make this to react with CH3, MgBr, CH3 in presence of dry ether, in presence of dry ether, complete the equation. If you have a carbon to which a OH group is bonded, if you have only one hydrogen, we call it as a secondary alcohol. The carbon to which a OH is bonded, if you have only one hydrogen, we call it as a secondary alcohol. See which alcohol you get in the third one. Complete the equation. Same way. Aita. Okay. So what is it we get here as? We get here as CH3, CO, MgBr. Here we get CH3 and here we get CH3. Subject this to hydrolysis. Subjected to hydrolysis, we get here as tertiary alcohol. So formaldehyde gives a primary alcohol. Other than formaldehyde, you get a secondary alcohol. If you use a ketone, you get a tertiary alcohol. Next preparation from aliphatic primary amine. Aliphatic primary amine, what you'll do is you'll take NaNO2, which we call it as a sodium nitrite, right? Sodium nitrite, treat this with HCl. You get here as NaCl plus HNO2. HNO2 is called as a nitrous acid. HNO2 is called as a nitrous acid. HNO2 is called as a nitrous acid. Take any primary amine, that is nothing but CH3NH2, which we call it as methylamine, which we call it as a methylamine. CH3NH2, which we call it as a methylamine. It is also called as a primary amine. Treat this with nitrous acid, HNO2. Treat this with nitrous acid. We get here as CH3OH. Nitrogen gas will be eliminated out with liberation of water. Nitrogen gas will be in competitive. They ask you which gas is liberated during the preparation of an alcohol. Diazotization also they ask. That is a nitrogen gas will be liberated. Copy down the equation. Benzylamine CH2 NH2. This we call it as a benzylamine. Benzylamine. Complete the equation. Complete the equation. Benzylamine. You are making it to react with HNO2. Get here as a benzyl alcohol. Benzyl alcohol liberating nitrogen gas and water. Liberating nitrogen gas and water. Right. Answer this question. Question number 18. An alkene CH3CH double bond CH2 is treated with B2H6. Follow your classwork, answer the question. Till now, whatever you people have written based on that, we have. An alkene when treated with B2H6, what is it we get? Whenever you treat it with B2H6, what is it I told you people? B2H6, diborane. BH3 twice we call them to be as a B2H6. Whenever you treat it with B2H6, we get a primary alcohol. Diborane hydroboration. When we are talking about hydroboration, B2H6 in presence of H2O2 is called as a hydroboration reaction. So we are supposed to get a primary alcohol, which we call them to be as option C. Okay. Next, the hydroboration oxidation reaction of alkene takes place according to anti-Markovnikov's rule. It takes place according to anti-Markovnikov's rule. Next, the Markovnikov's rule is not followed in. The Markovnikov's rule is not followed in. It is a option D, which we call it as a hydroboration reaction. It's a hydroboration reaction. Next one, a compound C3H6 on hydrolysis with dilute acid gives a product X. The same compound and hydroboration oxidation gives you product Y. Find X and Y. Take your classwork, write it. Right? So, it is nothing but C3H6. Since it is a hydroboration reaction, you can even tell this as CH3, CH double bond, CH2. CH3, CH double bond, CH2. On hydrolysis with dilute acid. On hydrolysis means you are supposed to add water molecule in presence of H plus ion. What is the product we get here as? CH3, CH double bond, CH2 plus water molecule with H plus ion. What is it we get here as? It follows Markovnikov's rule. Howda? It follows Markovnikov's rule. Since it follows Markovnikov's rule, we get here as CH3, CH. Here it will be OH, CH3. So in the first case, we will get 2 propanol. In the first case, we get 2 propanol, whereas with hydroboration, we get 1 propanol. With hydroboration, we get a 1 propanol. With the first case, it gives me 2 propanol. In the first case, I'll get 2 propanol because it follows Markovnikov's rule. In the second case, it is a hydroboration reaction which follows the 1 propanol. Okay. The compound that is most difficult to protonate is phenol. The compound that is most difficult to protonate is phenol. That is nothing but a benzene ring with OH. A benzene ring with OH. It is very difficult to protonate due to the steric resonance structure. Due to the resonance structure. Okay. Right. Next one, ಇವಾಗ ತಾನೇ ಮಾಡಿದೀವಿ ನಾವು. Preparation. Question number 23. Preparation from carbonyl group ಅಲ್ಲಿ ಮಾಡಿದೀವಿ ನೋಡಿ. ಪ್ರಾಡಕ್ಟ್ ಹೇಳಿ ನಂಗೆ. ಪ್ರಾಡಕ್ಟ್ ಹೇಳಿ. ಸರಿಯಾಗಿ ನೋಡಿ ಹೇಳಬೇಕು. ಆರ್ ಸಿ ಡಬಲ್ ಬಾಂಡ್ H. An aldehyde when you subject it to hydrogenation, that is reduction in presence of platinum or palladium, what is it we get here as? Option C, primary alcohol. Aldehyde gives always primary alcohol. Aldehyde gives always a primary alcohol. Okay. The reducing agent used to reduce ketone into secondary alcohol is reduce ketone to secondary alcohol. NaBH4, sodium borohydride, whereas these two are called as a oxidizing agent. Potassium dichromate, potassium permanganate, both are oxidizing agent. NaBH4 is a reducing agent. Right. Next, question number 25. Question number 25. Question number 25. The reducing agent used to reduce carboxylic acid to primary alcohol is excellent yield is. It is a lithium aluminium hydride. Lithium aluminium hydride. Lithium aluminium hydride. Okay. The next one. Find the product of A in the following reaction. Actually, sodium borohydride is a mild reducing agent. Aita? Sodium borohydride is a mild reducing agent. We cannot reduce this ester group. We cannot reduce ester group. So we can convert oxygen, the oxygen which is present here can be converted into an alcohol. So the product will be, it is option C. It will be option C. This is your in-text question. Nim in-text question alli idide idu. It is option C. The ester cannot be reduced. So we are going to reduce only double bond O. We get O. Equation barkoli idena. This is your in-text question. It is option C. In-text question. Okay. Next one. Next one. Primary alcohol. Primary alcohol can be prepared by reaction of formaldehyde with methyl magnesium iodide. Formaldehyde with methyl magnesium iodide. Methyl magnesium iodide. Then IUPAC name of the product when the reaction ethanol with methyl magnesium bromide. What is it you get here as? You people have written it. Check your book and tell me. That is nothing but CH3C double bond OH. This is called as ethanol. You are making this to react with methyl magnesium bromide. That is nothing but CH3MgBr. CH3MgBr. If you are not written, you can aram se make it out. It's not so difficult. CH3MgBr, so that you get here as CH3, CH, here it will be OH and here it will be CH3. So it is propane 2-ol, propane 2-ol, propane 2-ol, propane 2-ol. Okay. Next one. The IUPAC name of the product obtained when the reaction of acetone and methyl magnesium iodide is followed with hydrolysis. This you people have written. Methyl magnesium acetone. Acetone is nothing but propanone. CH3, C double bond O, CH3. You will make this to react with CH3, MgI. You people have written it. What is it we get here as? Option D, 2-methyl propane 2-ol, 2-methyl propane 2-ol, 2-methyl propane 2-ol, a tertiary alcohol. Right? Fine, guys. I'll continue in the next class and see to it you people study for your test.